If you'd like to make professional looking pyro, then it's going to be really helpful to start with an accurate definition. Most people, based on the reels and based on other things I see online, don't actually have a good definition of pyro. So here's my first question to you. If you just saw something blow up, let's say this building, what are you actually looking at? Well, we actually have many different things layered on top of each other to equal the pyro effect. We have smoke, we have flames, debris, there's probably sparks and embers flying around. And my point is that pyro interacts with the environment. It's not just a sphere that's being lit on fire or blown up. It's all about this interaction with the environment. It's all about combining various things together to make one big effect. So if it's not on your sites yet, I want you to think about this interaction with everything that you do. If you're building, let's say, some sort of explosion, think about where the heat is coming from based on the environment. If you have a missile that's hitting the ground, what direction is that missile hitting from, and how does that impact the resulting velocity of the explosion? My point is that if you want professional pyro, you need to always be thinking about this interaction. And that's what's going to take your stuff to the next level. Now that being said, pyro is also not a beginner topic. I'm going to assume that you already have the basics down with Houdini, because in order to save time, I'm not going to spend time really talking about how to cache out files or how to add an HDR to your scene or things like that. And I've also have other videos that really go into that if that's where you're at. That all being said, let's now dive into the details. In this course, I'll be talking about volumes, which encompass the smoke and flame portion of a pyro effect. And these volumes are made up of voxels. Voxels are basically tiny little cubes that are flying around in your 3D scene. And these cubes store values. They store values and they also belong to a field. So the way I think of it is that a field identifies a group of voxels and what they're used for. Over here, we would have, let's say, a smoke field called density. Or for the flames, this might be a field called heat. And so the group of voxels really describes what they're used for. That's the field. The value inside those voxels might describe how much smoke is at that one spot or how hot the flames are at a particular spot. And that all eventually goes to inform the render engine of how it should shade these volumes. So as I mentioned, this is kind of a visual of what's going on. Now, in addition to the stuff that we see in the render, you can also feed the solver different fields so that you can control the behavior of what's going on. In this example, if we have, let's say, a velocity field like this, we have a bunch of voxels that are storing velocities, which describe the direction in which things are going. This could then be used to, let's say, tell the density and the heat where it should go over time. This is also true for, let's say, particles that are being ejected through the air. And it's not just velocity, you can do fields for all kinds of different things to control the specific behavior that you want from the pyro solver. Here's a second question. What generally needs to happen in Houdini so that we can get flames, smoke, steam? Let's think about the overall process before we get into this. And I actually like to start with the end in mind. I kind of like going backwards in how this all works so that you can understand what's going on. We have a pyro solver, and our pyro solver eventually will give us all the fields we want so that we can render. So this could be our density, which is our smoke, our heat, perhaps our velocity to calculate some sort of motion blur with this. Basically, anything you want to use to help to render is what we want from the pyro solver. Now, this pyro solver can't just create fire out of nothing. We have to feed the pyro solver volumes so that it can work with something and give us these fields. So the thing that contains those volumes is a smoke object. The smoke object is basically like a bucket. It contains a bunch of volumes, and that's what the pyro solver is allowed to work on. Now, the main idea is that the smoke object will get what it needs from the volume source node. and the volume source node will get what it needs from our geometry. So this is a little bit confusing at first, and let me try to explain what's going on. So I like to think of the smoke object as a bucket. This volume source is kind of like filling the bucket full of volumes. And so what does this do? Well, it grabs the volumes from SOPs and puts it in the smoke object. The reason why we do this is because it's going to prepare all these different fields for the smoke object so that it can work nicely with the pyrosolver. So if we're taking, let's say, density or temperature or fuel, all these different fields affect the way in which the pyrosolver will work. And so the volume source is there to prepare these fields for the solver. Now, these fields originate from our geometry, which is our SOPs, right? And so here's what the process looks like in order to generate these fields. We're going to start with some particles. We will control the initial motion and location of where these volumes will start. We'll also add a bunch of variety to the data. We'll attach attributes to these points so that with these fields, they're going to start with different values and have different spots that are more intense or less intense. This will help break up our simulation to start. And then once we have the attributes on these particles, we're going to rasterize them. That means turn them into volumes so that now it can go to the volume source, go to the smoke object, go to the pyrosolver, and we're left with our final result. In the next lesson, let's create some geometry which can represent the beginnings of our steam.